All right, so we are looking at 16B this morning. I know that you guys will be in and out this lesson, so we are just going to record this lesson and then you have access to it to catch up at home or when suits you. Last lesson we looked at, or last week we looked at probability density functions. What do you remember about probability density functions? Okay, good. The integral from negative infinity to positive infinity equals 1, and all of the probabilities have to be positive, yeah, greater than or equal to 0. Okay, this is a snip from your formula sheet. The mean and variance, we're going to look at mean and median this morning, and then Miss Kinnear is going to look at variance. So you have these formulas here, but for any continuous random variable with the probability density function that is defined by f, the mean is given by this formula here. We have seen E of X. What does E of X stand for? The mean, yes. And what is it formally standing for? Yeah, expected value. Good. So synonymous to the mean is expected value. And what do you notice about that formula there? What's kind of snuck into the integral? Yeah, we have to multiply the probability density function by X. And we also will use this Greek letter mu, which is basically like a bit of an M with a larger tail at the beginning to represent the mean as well. So here we go. It says find the expected value of the random variable X, which has the probability density function given there by that rule. So we know now from that formula the expected value of X is given by the integral from negative infinity to positive infinity of X times f of X, all with respect to X. What domain has been given for this function? Oh guys, there's not many. You're gonna have to, yeah, 0 and 2. You're gonna have to pull the team. 0, 2, X times by what is f of X? What is the function of X between 0 and 2? I heard it, I think. 0.5x, good. With respect to X. So now if we were to integrate that, what would we do?
Can you integrate the product like in that form? What?
Combine it. Okay, that sounds good to me. Integral 0 to 2 of 0.5 x squared with respect to x. And then what might you do to make your life a bit easier? Move the half outside.
Things, yeah.
Good. So I'm just going to take that half out the front because we can pull out any constants. And now we can integrate that as 0.5 times x cubed on 3 between 0 and 2, which is going to, I'll just drag this up to the top here, going to be a half times, all right, the upper bound is 2, so we sub that in. What is 2 cubed? 8 over 3, good. And then we are going to subtract the lower bound, which is 0. What's 0 cubed? 0 over 3. So then we get a half times 8/3. Cross simplify, and your final answer is 4/3. So all we have done there is we've applied our expected value formula, which is just X times the probability density function as it's given in the question, and integrated over that boundary. Is that all right? It's just one of those things, it's a formula that you know and you just apply. All right. Let's leave the practicing for a little bit. Okay, here are some other properties for you. If we are looking for the expected value of, this is x, but something has been changed. We have multiplied x by a number, a constant, and we have added a constant to x. We're actually able to manipulate that, and you can separate it out into this form here. So the expected value of a number times that random variable x plus b is going to be equal to a times the expected value of x, and then you just add the b on at the end. Now, this is really just a special case of the formula that's written below. So if we are talking about finding the expected value of g of x is talking about a composite function. What is a composite function? What are composite functions? Yep, a function inside of a function. Good. So if the integral exists and you need to find the expected value of a composite function, have a look at what we do. We keep the original PDF. So that's my original probability density function of the random variable x. And then we multiply that by g of x, which you can see is just the function defined on the outside. So I think this will just make a little bit more sense when you see it in action. So let's just have a little bit of a look. All right, x is the random variable with the probability density function defined below. So we've got f of x equals 0.5x. Now, the question has asked us to find the expected value of x squared. So we want to find the expected value of x squared. So if you had to define g of x, what would that function look like? What is the function? It's the variable. Any takers? X squared, what function is that? It's not a trick question. What is happening here? X is being squared, that's it, that's all it is. So this is saying g of x is x squared. So if we now plug into that formula, we get the integral from negative infinity to positive infinity of g of x, which is just x squared, times by f of x. What's f of x? 0.5, all with respect to x. And again, we can restrict our domain, and I might even actually factorize out that 0.5 while I'm at it. And I have forgotten something. What have I forgotten? Yeah, thanks. I have forgotten my x up there. And so on the inside, I get x cubed dx, which equals a half side of x to the power of 4 on 4 from 2 to 0 to 2, which gives me a half times 2 to the power of 4. What do we get for 2 to the power of 4?
Well,
16. Thanks, Jay. Minus 0 on 4. So a half of 4 is 2. So the expected value of the the continuous random variable x all squared is given by whatever the function is, so x squared times by the original function f of x. Right, try the next one. Exact same logic applies. Don't overthink it. Just go with your gut. All right, so the expected value of e to that continuous random variable x. So when we have a continuous random variable and there's a function inside a function, so we can see our function, sorry, OneNote's having a little bit of fun with me. There we go. All right, so we've got b is going to be the expected value of e raised to that power of x. Can you see that x I've drawn? Is that our normal, x is just a variable that we normally deal with? Can you see that I've actually drawn it intentionally different? That's a capital X. That capital X is representing the continuous random variable. Okay, so we're definitely using some different notation there. It's going to be the integral from negative infinity to positive infinity of g of x, which is e to the x, times f of x, which was 0.5x, all with respect to x. And now we'll just come in and restrict our domains, factor out the constant, 0 to 2, e to the x of x with respect to x. And when you put that in your calculator, what do we get? Anyone? Thank you, 4.195. Perfect. Okay, this one, A, is super, super important. Make sure you've got your head around A because you're not going to be able to do variance unless you can do A. So A is really important, but B is not too hard either. Okay, hands up if you've been here since the start of the lesson. One of us, two of us, three of us. Great. Okay, so my people that have been here since the start of the lesson, what can you tell me? What do you think is important for the people that have just walked in? What would you be teaching them? If we have x is a continuous random variable, what is mu? The mean. What's another way of saying the mean? Expected value. And we can write that like that. And what is the formula for the expected value of a continuous random variable? Come on. Almost.
Not derivative, otherwise.
Integral, good. From negative infinity to positive infinity of x, little x, times whatever your probability density function is defined as. So that was the first thing that we covered this morning. The expected value for a continuous random variable is given by that formula. Cool. Good to know. Yes, they do. P of x. Okay, great. So yes, Miss Kenny has just said they use P in your formula. So that's fine, P of x, it's just representing your probability density function. And then the next thing that we looked at was if you have a composite function, like the question asked you to find the expected value of a function of x, it is going to be the integral from negative infinity to positive infinity of whatever that function is times by the probability density function. All right, so the example that we just did looked at x squared is going to be the integral from negative infinity to positive infinity of x squared times whatever your probability density function is. Okay, so even if you have come in late now, I want you to stop trying to catch up on notes. I want you to tune into this next bit while I'm teaching it live, okay? So please just focus in. All right, percentiles. If somebody says, hey, you're in the 75th percentile of something, what does that mean? Does that mean you're on the upper end or the lower end? Yep. Your result, 75% of people are lower than your result. Yep. So if we were drawing it on, this is a bell curve, roughly 75%, we're looking somewhere like here, and we are saying that this is you, and this area underneath the curve is 75%. So what area is to the right of you? 25%. Good. And if we start going back to our probability density functions, you know that if this is my P of X, my probability density function, what is the total area underneath a PDF? 1. The total area underneath a PDF is 1. Good. So the integral of a probability density function has to equal 1 over the entire domain of that function. So if I was interested in finding, well, what result do I need to get to if I want to find out 75th percentile, how could I do that? I want to find out, I know I'm the 75th percentile. I need to find out what my result is to get me to that 75th percentile. What do you think we could do? Have a think. We want to find the area from the start all the way up into where you are. And what do we want that area to equal? Yeah, 0.75. Sensational. So if we wanted to find, what would be my lower bound for that integral? 0? Yeah, we'll just go negative infinity. It might be 0, but it's not necessarily going to be 0 because your probability density functions might be defined for negative values of x. So we'll go negative infinity. Let's call this number up here, we don't know what it is yet, we'll call it P. So I'm going to integrate all the way up into P. What am I going to integrate? What goes inside the integral? P of x, good. Okay, so maybe we shouldn't use P up there. Let's use a different number, letter. What do we want to use? A. And we derive that, integrate that with respect to x, and we want that area, that green shaded space, if we were finding the 75th percentile, we would want that area to equal 0.75. Is it always going to equal 0.75? No, it's going to be dependent on the question. All right, so for example, here is a PDF defined for the duration of telephone calls to the order department of a large company, and it's a random variable, x minutes, with the probability density function defined there. Find the value of A such that 90% of phone calls last less than a minute. So we are looking for, if you imagine what this graph is, you can maybe picture that graph. It's a little bit tricky, but you've got an exponential that has been dilated parallel to x by a factor of -3. It will be the reciprocal of this. And then I'm just going to stop trying to visualize that one. And then dilated parallel to the y-axis by a factor of 1/3.
When b is negative, which axis do you reflect through?
Got a negative b, so where is it reflecting?
X or y axis? It's a y, yeah. When your b is negative, because b is normally to do with x, when it's negative, it reflects in y, right? It's just the reverse. So because it makes all your x values, instead of being positive, it makes them negative. So instead of it being a normal e to the x function, which is what we've got there, it's going to be the reverse of that. So flip the other way. It is only going to be defined for values greater than 0, and it's going to be stretched this way and squished this way. So it's this kind of, it'll look very similar in the end. But what you need to really be mindful of is the fact that this is going to go the opposite way through, right? If we compress our vertical axis by a factor of 1/3, what is that going to do to your y-intercept? If you kind of compress, instead of it going through it.
Where is our y-intercept at the moment? 1, good. So now we need to sketch 1/3 e to the negative x. What's that going to look like? 3? 1/3. There it is.
The b value is the reciprocal, so that's going to now stretch it horizontally by a factor of 3. Anything on the y-axis, though, is not going to move, is it? Because it's already on, it's going to stay there. It's just the distances from that axis get 3 times larger.
All right, so now we are trying to find the value of A such that 90% of phone calls, so we've got this PDF here in blue, a rough sketch, and we want to find the area under that such that here's my value of A. We want this area to be 90%, 0.9. So, formula. We are going to integrate from negative infinity. In this case, what is my lower bound going to be? Great job, 0. My upper bound, we don't know what we're integrating up until. That's what that A point is. We put in our function with respect to x, and we want that to be equal to what? Great job, 0.9, that's right. Okay, and you could look to make your life a little bit easier. Actually, the 1/3 is going to cancel out anyway, but start integrating.
You could graph the integral and graph 0.9 and then find your lowest weight. Would that not work? You've got the extra variable.
It's a good idea. I would try it. If you plotted that.
See what I mean? There. I'll have a look. See if it works.
Eventually. Even leave it in terms of logs, natural logs, and then once ready and you have a natural log answer, you can use a calculator. Okay, hands up if you got somewhere close to this. How do we go? Do we integrate, substitute? Yeah. Once we get here, yes, you can say, right, well, that means A equals -3 ln of 0.1. Can anyone think of a more simplified version that we could make that? Let's have a look at what 0.1 is. What is 0.1? 1/10, okay, which is the same thing as 10 to the power of -1. And now I've got that power, what can I do? Multiply it by the -3. So A actually is just going to equal 3 ln. Just good to think about how we can be manipulating those logs a little bit more. And to 3 decimal places, what does that equal? Perfect. So therefore, 90% of calls last less than 6.908 minutes. Oh, nice. Did you just sketch the integral? Did you compute the integral or did the calculator compute it? Okay. All right, if we were in tech-free mode, you could get to here, right? We would expect you to get here, tech-free. Tech active, you'd obviously, what would we be doing if this was tech active? What would we do if this was tech active? Solve n, that's right. Where? Line number 1. If it was tech active, solve n. Let's try that now, please. Tech active, solve n.
So you'd have to put an X where the A is. I did try solving, I just did graph mode.
All right, putting that into solve n puts your calculator in a state of distress. So we will look at how to do that in graph mode once our calculators come back to join us. Question for you. What do you know about the median? What's your gut say? Median, you think? Middle. Great. If it's the middle, what percentage of data is on either side of the median? 50%. Great. So if I asked you to find the median of a continuous random variable, write down what formula you would be solving to get to the median. My solve n has just kicked in.
Anybody else has just come through? I'll give it a little bit longer, it will do.
Okay, so we were just looking at if I wanted the 75th percentile, I would solve that. If I wanted the median then, and you have just told me that the median is when we get 50% on one side of the median and 50% of data on the other side. So the median formula, therefore, is going to be found by integrating from, lower bound is -infinity. Upper bound, what's a good letter for median? Great. M, we have our probability density function. We derive that with respect to x, and that integral should equal what percentage? 50%, so 0.5. So that is your final formula for this lesson, the median formula. You integrate and you make that integral equal 0.5 and you solve. So I'm just going to do, so please have a go finding the median value of that probability density function. Alrighty, so you should be integrating from 0 to m of 2 outside of 1 take x with respect to x, and that needs to equal 0.5. I need you to be able to do this tech free before you jump to tech active. So take that 2 outside, integrate 1 minus x, you get x minus x squared on 2 from m to 0 equals 0.5. Substitute in, we're going to have m take m squared on 2 minus 0 take 0 squared on 2 equals 0.5. So we get 2m minus m squared equals a half. So then we have m squared minus 2m plus a half equals 0. And when we get here, if this was tech free, we would try to factorize, we would be unsuccessful. So then what would you do? What would you do if you could not factorize? Quadratic formula probably, or complete the square is fine. Yep. And we put in our calculator, or we can do complete the square or quadratic formula. I'm going to go quadratic formula. B squared minus 4 times 1 times a half. All right. So we've got 2 plus or minus root 2 all divided by 2. That's where you were at tech free. That would be okay. Tech active now. Do you want to talk me through the calculator?
No, you need to think about which one lies within the domain.
Yeah, right. Yep. Okay. So we've got 2 solutions here. One of the solutions, what is the square root of 2 roughly? It's between 1 and 2. Good, it's about 1.7. So we have got 1.4, sorry. You've got roughly 2 plus 1.4-ish divided by 2, or 2 minus 1.4-ish divided by 2. So this is going to be roughly what have we got? 1.7. 3.4 divided by 2 is 1.7. Or what's the other answer roughly going to be? 0.3. Okay, good. Now let's go back up and look at the question. The question says the PDF exists between 0 and 1. So we're thinking about Vespa, and we're thinking about pondering our solutions. What do we need to do? Reject. Which one?
So the 2
plus square root 2. Because why? Communicate your logic. Yeah, because it's less than 1. It's negative.
It's outside.
It's greater than 1. Good.
Yeah, or you can
haven't even been here. Jumps right in. Because it is outside of the domain.
Another way you can think about it is like split the fraction because it's plus root 2 on 2? Well, 2 on 2 is 1, and then when you add on half of root 2, it's going to be over 1, isn't it? Like, that's another way to think about it. Yeah, so if you did, you'd have to split the fraction first. So you'd have to write it as 1 plus root 2 on 2. Like you split the two sections. And then, because you know your upper bound is 1, then doing 1 plus a half of a root 2, it's going to be
larger than 1.
Yeah, right? Does that make some sense?
I was just thinking that it'd be easier to think of 1 divided by the square root of 2 than thinking about the square root of 2 divided by 2. But I guess either one's not very easy to think about.
I find it easier to think half of root 2 personally, but
I was just like, oh, if it helps my brain think about it, yeah, that's why I rationalize it.
I would not do that. I'd be like half of root 2, because I'd be like, root 2 is between 1 and 2.
Yeah.
Half of that's going to be like half, you know.
All right, so we've got the median value equals 2 minus root 2 on 2.
Right, let's find that using graph mode.
Yeah, you want to talk? Okay, so using the tech active mode of solving this, you would need to still state that formula there at the very top, right? You don't need to, though, then go and do all the integral stuff if this was on a tech active paper and you're finding the median. All you would do at this point, let's just put that there, this to the other side, you go to your graph mode. Let's just delete these functions. And you put in the integral function, so you need to press options, calculate the integral of 2 brackets, 1 take x, close brackets, between 0, and instead of writing m up there, you just put x. And then the other function, because we want this to find the median, not the 95th percentile or any of those other things, we're going to sub this into be 0.005, yes, 5, right? Because I want it to equal half. I want to find when is the area under this function equal to a half, because that is where the median would be, because the median is always halfway between. So you're wanting to say areas under a probability density function normally equal to 1. I want to find out where does it equal half, because that would be the median. So that's what you're solving for. Sorry, you press option, calc. Yep. Once you've got both of those, I'm just going to make sure like I have a reasonable view window, I reckon, just because shift V window. Oh, that's just going to annoy me now. Get off there. Shift V window. It's going to go standard to begin with. Draw. Here we go. Okay, so can you see it sketch my integral of the function? So the integral of a linear will obviously be a quadratic because it's always 1 degree higher. And then if you press G solve intersects, this one hopefully might take a little bit quicker. So it gives you the two values of the function. And obviously, because we know this probability density function is only defined, well, we can actually add that in here, can't we? I add, just trying to think.
Do you remember how to restrict our domain? Yeah, commas,
comma. Was it 0, 1, was it?
Yep. 0 up comma to 1. And there we go.
So all I did then, just so that you can just see, I've just restricted my domain so it doesn't give me the two solutions. So I just said this is only, we're only looking for solutions between 0 and 1. So I've just restricted my domain between those two values. Then I press G solve, intersect, and it gives me the one solution then. I don't need to reject an alternative one. If this was on your calculator paper though, and you are using this technique, you would need to sketch that, right? You would have to show this is what I'm solving for. I've sketched the integral function. I'm setting when is my integral equal to a half. It occurs at x is this value.
Does that make sense to everyone? Yeah? So if I just zoom in a little bit, in. So what do you know the area under that blue curve is going to be? 1. So if I drew a vertical line through where that red line intersects the blue line, the area on the left of that would be a half, and the area on the right of that would also be a half. So you could show that diagrammatically as well. You could sort of say the area to the left of where that red line intersects is 1/2, the area to the right of where that intersects is 1/2. Okay? Or is it above and below? It might be above and below in that case. Yeah, it's above and below, isn't it? I was just looking at that thing, and that is not the case. Yeah, the area above and the area below is 1/2. Yeah. All right.